In this video, we're going to be going through the questions on page 33, and for some of them, I'm just going to kind of help you see what the questions are talking about. So for number 19, Josie has 4 units of fencing. 2 are 5 feet long, and the others measure 6 feet. What that means, y'all, is that we have opposite sides are congruent. So in the pictures here, I have the 2 different ways that she could arrange these for the opposite sides to be congruent. One could be a parallelogram and the other could be a rectangle, and there's the 2 pictures to help you see that. For number 20, Judith draws a quadrilateral that has sides measuring 8, 9, 8, 9. And so once again, we can see here that we have opposite sides congruent. So it could be a parallelogram or a rectangle. But then it goes on to say that the angles are all right angles, which means it has to be the rectangle. And I can draw one for you real quick. That would be the 8s and the 9s. 8 and 9, and then we have our 4 right angles. All right, for number 21, Tony draws a quadrilateral that has the sides which each measure 9 inches in length. So it could be a square or it could be a rhombus. And because it says that none of the angles is a right angle, that's why we're going with rhombus. In number 22, Reagan has 4 pipes. If she arranges them into the shape of a trapezoid, which set could be the lengths of the pipes that she uses? Now, I want to remind you guys, for a trapezoid, we have 2 types. We have the isosceles trapezoid, because these side lengths are the same as each other. They're congruent. We also have something called the right trapezoid, where those are right angles right here. And obviously, my sketching is a little messed up. And so the goal is to figure out which set of lengths here could be for one of these 2 shapes. Now, F happens to be the right answer, and I'm going to explain real quick that G, since they're all the same, that would either be a square or a rhombus. Here we have opposite sides congruent, 2 10s and 2 7s, so that would be either a parallelogram or a rectangle. And for J, this one might have caught some of your attention, maybe being over here. But there's 3, 3, and 3. So if we have a 3, a 3, and a 3, and then a 15, that one's actually not even going to be a polygon because that side would overlap. It's too long. All right, so it's not J. Now here we have a 7, a 10, a 5, and a 4. So for example, we could have the 10 here being the longest side, then the 7, and then a 5, and then a 4. And that would be the dimensions of a right trapezoid. For number 23, Eric draws a quadrilateral that has 2 pairs of parallel sides. So 2 pairs knocks out the trapezoid. 2 pairs of congruent angles. Now in B and C, all angles are congruent at 90 degrees. So we know it's got to be D because here's one set of congruent angles, and then the other ones would be the acute angles, and they're congruent. So there's the 2 different sets of congruent angles. And they're not right angles. It also goes on to say not right angles. So again, we can knock out B and C. And so it has to be D. All right, number 24. Bo draws a quadrilateral that has exactly 1 pair of parallel sides. So if it's got exactly 1 pair of parallel sides, that means it has to be a trapezoid. It also goes on to say that there are 2 congruent angles. And right here we can see the 2 90-degree angles. So this would be the trapezoid that Bo draws. And for number 25, we have that opposite angles in a rhombus measure 135. I know it has to be these because those are obtuse. I wouldn't put those here because these are acute. So then it asks us what would be the measures of these other angles. So I'm adding 135 plus 135, and that's where I'm getting 270. So now the whole sum would be 360. I'm subtracting the 270 that we already have, and I see that these 2 angles would have to add up to be 90. So I've now divided that by 2 to get D, 45 degrees. And now we are done with page 33. Thank you.